Hi friends, my name is Bhavish Sandure. I am the student of B.Pharm. Then friends, today's topic is separation of colloids. In colloids of first unit, then separation of colloids, the mechanical dispersion is the first, then electrical dispersion or Bladik's arc method is the second, then peptidation, then third, the condensation method, fourth. Then the first is mechanical dispersion. In this method, the substances is first ground to coarse particle. It is then mixed with dispersion medium to get a suspension. The suspension is then grinded in a colloidal mill. It consists of two metallic discs nearly touching each other and rotating in opposite direction at a very high speed above. Then the 7000 revolution per minute. The space between the discs of the mill is so adjusted that coarse suspension is subjected to great shearing force, giving rise to particle of colloidal size. Then colloidal solution of black ink, paint, varnish and dyes etc. are obtained by this method. Then second is by electrical dispersion or Bladik's arc method. In this method is used to prepare soles of platinum, silver, copper or gold. The metal whose sole is to be prepared is made as two electrodes which immerse in dispersion medium such as water etc. The dispersed medium is kept cool by ice. Then an electric arc is struck between the electrodes. The tremendous heat generated by this method gives colloidal solution. The colloidal solution is stabilized by adding a small amount of potassium hydroxide KOH to it. Then third is by peptidation. This process of converting a freshly prepared precipitate into the colloidal from the addition of suitable electrolyte is called peptidation. Then the cause of peptidation is the absorption of the ion of the electrolyte by the particle of the precipitate. The electrolyte used for this purpose is called peptidizing agent or stabilizing agent. The important peptidizing agents are sugar, gum, gelatin and electrolytes. Then the fourth is condensation method. In condensation method, the smaller particle of the dispersed phase are aggregated to form large particle of colloidal dimension. Some important condensation methods are described below. And solution of substances like mercury and sulfur are prepared by passing their vapor through a cold water containing a suitable stabilizer such as ammonium salt or citrate. Then B. By excessive cooling. A colloidal solution of ice in an organic solvent like ether or chloroform can be prepared by freezing a solution of water in the solvent. The molecule of water which can no longer be held in solution separately combine to form particle of colloidal size by exchange of solvent. Third, then colloidal solution of a certain substance such as sulfur, phosphorus, which are soluble in alcohol but insoluble in water can be prepared by pouring their alcoholic solution in excess of water. For example, alcoholic solution of sulfur on pouring into water gives milky or colloidal solution of the sulfur. Then the D fourth, chemical method. Colloids can be prepared by following chemical method. Then first, oxidation. Addition of oxygen and removal of hydrogen is called oxidation. For example, colloidal solution of sulfur can be prepared by oxidizing an aqueous solution of H2S with the suitable oxidizing agent such as bromine water. Then first H2S plus Br2 then gives twice HBr plus S. Then twice H2S plus SO2 gives 2 H2O plus 3S. H2 means water. Then second is reduction. The addition of hydrogen and removal of oxygen is called reduction. For example, gold salt can be obtained by reducing a dilute aqueous solution of a gold with stannous chloride. 2AuCl3 plus 3SnCl2, then 3SnCl4 plus 2Au. Then the hydrolysis, it is the breakdown of water. The salt of ferric hydroxide and aluminum hydroxide can be saved preparation by boiling the aqueous solution of the corresponding chlorides. For example, FeCl3 plus thrice H2S gives FeOH3 plus thrice HCl. Then the fourth, double composition. The salt of inorganic soluble salts such as arsenic sulfide, silver halide, etc. may be prepared by using double composition reaction. For example, the arsenic sulfide salt can be prepared by passing H2S gas through a dilute aqueous solution of arsenic oxide. Then As2O3 plus thrice H2S gives As2S3OH thrice plus thrice H2O. Then the domain membrane equilibrium. Two solutions containing electrolytes are separated by membrane which is impermeable to one of the ion of an electrolyte. It was found that at equilibrium an unequal distribution occurs from the permeable ion on both sides of membrane. At equilibrium, the osmotic pressure of the two solutions will be different and its two reference electrodes such as calomel electrodes are put into the two solution, then the difference of the potential will be the set up. This type of equilibrium is known as Donan membrane equilibrium. Then component of a solution, then internal solution, external solution and semi-permeable membrane. Then first, internal solution, it is a solution of an electrolyte containing ion penetrating ion of about colloidal dimension and ion small enough to be penetrable. Then the external solution, it is a solution of electrolyte containing both penetrable ion. Then the semi-permeable membrane, it separates the two solution and is permeable to all the solution.